Comes in two components. There's the actual board, um, which transmits the photograph to the Nessie board through UART, and then there is the actual lens, which plugs into the camera. There are two lenses available from Electronics 123, which is where the cameras can be ordered. There's this one which goes a further distance, which can focus further away, and this one which can focus for nearer close-up applications. Both of which are mounted onto this camera through the screw holes. For this application, we're going to be using this close-up one here. It did come with a lens cover, and I'll just keep the lens cover on for now. It can easily be mounted onto the Nessie board by putting it on there, and it comes with some screws that can screw through the holes in the back. Just like so. And now we have the camera put together, which you can go and mount on the Nessie board. The camera communicates using UART and plugs into the 2mm headers, which can be accessed at JP7, just to the right of the microcontroller. It can also be accessed through the externals camera slot, which is at JP13, if you want to wire the camera. But for now, we're gonna go ahead and plug it in using the 2mm female headers at JP7. The power for the camera must be can be controlled at up here at JP15. If you look in the back, it's JP15. This allows you to either have the camera consistently on, or allow you to change the status of the camera, so you can go from on to off. For this application, we're going to go ahead and use the fact that it's constantly on, so it's always on, which is the right pin. The left pin here is it allows you to control whether the camera is on, and the right pin allows you to keep it always on. So just tie those to the center pin, and that'll allow you to control the camera's power. So I'm going to go ahead and tie the right pin to the center pin here. And then I'll trim off any excess lead. In addition to the camera, we're also going to need a micro SD card here. We're going to go ahead and put that in the primary SD card slot. If you want to use both the primary and the secondary SD card slot, you're going to need industrial grade SD cards, because industrial grade SD cards will work with the Nessie's firmware in order to allow their simultaneous use. So now our board is configured. We can go ahead and jump to programming it.
So to demonstrate the use of the camera, we also have to explore the date-time code module. So go ahead and open up a new project in MPLAB X. If you don't know how to create a new project with the main file, there's another video explaining that. And here's the outline of the code. So we're going to start off by including the camera module. So we'll go ahead and type # include, and then camera.h. And also, because we're going to be using the datetime module, I'm also going to include datetime.h. The including of these two header files isn't actually necessary, because when I included nessie.h, these two header files were automatically included. So we're just going to write a little bit of a pseudocode here to explain kind of what we're going to do here. So first of all, we're going to initialize the camera, and then we're also going to set the time. It's May 25th, so we're going to set the time to May 25th. And then that's all for the initialization, and we'll go into our while loop. We're going to make a program so that when the button is pressed, it will take a picture and then store that to the SD card. So we're going to go ahead and do the if button is pressed once. Then we're gonna take a picture, but to do that we also want to indicate that we're gonna take a picture. So we're gonna turn the blue LEDs on as dim as possible so it doesn't interfere with the picture. If you have a dark environment, you can obviously make those go on brighter, but just for now, they're just an indicator. And then also, before that, we're going to use some of the button code here. I'm not really going to get into depth into the button code, but first we're going to disable the buttons identification of keystrokes. So after this, while this code is being executed, the NESI board won't pick up those keystrokes because they're irrelevant. If you want to get into depth on how the button works, there's another video explaining that. So we're going to turn the blue LEDs on, then we're going to actually take the picture and store, and I should mention that we're going to store it as the current date and time. And then we're going to go ahead and turn the blue LEDs off. Then we'll go ahead and enable the picking up of strokes, of button strokes again. So now it'll be able to take second pictures and so forth. So that's the basic outline of what our code will look like. We can go ahead and initialize the camera here with the init function, so camera.init. And then setting the date and time can be used by creating a date and time object. So how we're going to do this is we'll have a date and time object called timetemp, because this is the temporary time that we're going to create that time here, and then we're going to use that time to set the date time to that time. So we'll go ahead and create that time by adjusting its properties. So timetemp dot, and then there's all these different properties: date, day, hour, minute, month, second, and we're just going to go ahead and adjust them in kind of an incrementing order. We'll go ahead and do the hour, minute, and second first, and then the month, day, and the year. So the hour, time, date, dot hour, and then you're going to do equals, because that's a variable inside of there. So you're going to set that variable equal to the hour, and that's also the hour is in 24-hour time. So it's 1 o'clock p.m. or it's 1:46 p.m. I'm going to go ahead and set that to 13 because of military time. 1 o'clock p.m. is 13. And then timetemp dot minute. It is 1:46, so 46. And then timetemp dot second will be equal to 0 because I'm not keeping track of the second. That doesn't really matter. And then we'll go ahead and set the timetemp dot month, and then it is May. So we can go ahead and type May in all caps. That's an enumerated value, so you can choose one of the 12 months by typing it. Note that if you're in the month February, it's actually misspelled in the code. It's not spelled February. That would be incorrect. It's misspelled February. So just keep that in mind if it's February. But we're in May, so I'm going to go ahead and set that to May. And then we're also going to set timetemp dot day. And it is the 25th. And then timetemp dot year. And it is 2014. So we're going to type 14. And then we have our timetemp date and time created. It has all of those values set. And then we can go ahead and use the date time dot set function. There are a few functions in the date time. There's toStamp, to, sub, set, parse stamp, new, init, get stamp, get, CMP, and add. You won't really need very many of these. Get stamp is what we'll be using for the camera function. That'll get the current time. But here we're going to use the function set. So we're going to set, and that takes one parameter, which is a date and time variable. So we're going to type timetemp, and that passes this timetemp object that we created into the datetime.set function. So it'll use that time and temp, or the time that we just created to set it. So now that we have set the time and date, we can go ahead and work on this while loop here. So if the button is pressed once, we can use a button function. I'm not going to get into depth as to the button functions here, but if we're going to put an if gate there, and then button dot get stroke. This actually returns another enumerated value. There's keystroke underscore none. There's keystroke single and keystroke double. We're going to use keystroke single here. So button dot get stroke returns how many times the button has been pressed since the last calling of get stroke. So we're going to use two equal signs. One equal sign is not valid because that actually sets the get stroke equal to that, and that's just not possible in an if gate. So we're going to use two equal signs, and then keystroke underscore single. And then we're also going to put our brackets here to encapsulate this code. And then we're going to disable button strokes by button.disable stroke. And then we're going to turn the blue LEDs on by going LEDB duty cycle 1. Again, I don't want them too bright, so I'm just using 1. It will be on very little of the time, but it'll be visible. And then I'm going to take the picture. I'm actually going to write a new function for that, so I'm just going to put get picture here, just like so. That's not a function, so it will return an error. And then I'm going to turn the blue LEDs back off by setting their duty cycle to 0. And then I'm going to re-enable button strokes by going button.enable stroke. Not very much of this code is actually related to the actual camera and the date time, so I'm not really going to go into it. But for each one of these functions, there will be another video in the code modules section that will explain it more in depth. So now I'm going to go and write this getPicture function. I'm going to go and put the getPicture function above our main function because I don't want to prototype it. So I'll explain that in just a second. But I can have a boolean. It's going to return a boolean, a true or false value, and then getPicture. And it's not going to take any parameters. And because it's not going to take any parameters, and because this is kind of doubling as a prototype, I have to put void there. If I don't put void there, it's also valid, but you'll have to prototype it above. And what a prototype is it's declaring the function to the C language. So if I were to put this below here, getPicture, it looks like it would be fine, but if I were to build it, it would actually not run correctly, simply because it's processing this in a very linear order. So it gets down here and it says getPicture, and it doesn't know what getPicture is yet because it hasn't reached it. So that's why you would put it up top here. If you wanted to put it down there, and you completely could, you would just have to prototype it up here, and you can do that by declaring the function boolean getPicture and then void. You do have to put void in prototypes. You don't have to put it in the actual function, but you do have to put it in prototypes. So that would compile much better than, see, down here. This is before I added the prototype. It says implicit declaration of function getPicture, and I haven't actually declared it yet. So now, because I put that prototype up there, if I were to build it right now, it would actually build just fine. And it's giving me that error because it's supposed to return a boolean, but I didn't put a return statement in there. It could be easily fixed by saying return true. That would fix that error. But we're not going to put that in there because we'll have it return like a success or a failure. So we're going to go ahead and start writing that function by declaring or by creating a variable to store the file name. So that variable is going to be a character array called, which is a char. It's a character, and then file name, and then equals 0 because it's an array. And then we have to declare the size of the array, which is going to be 32 bits long, just as a maximum here. It doesn't have to fill up that entire area. So like if I were to say equals like Ryan, it would be valid because even though that's only taking up 4 characters, it has an allocated 32 spaces for characters, so that would be valid. But we're not going to put anything in it right now, so we're just going to put 0 there. Then we're going to write the datetime.getStamp function to that. So we're going to use the C language's sprintf function, and that takes 2 parameters mainly. One of them is the variable which you'll be storing or renaming, so file name, and then the other is the actual string of text that you want to store in that variable. So it could be datetime .jpg because it's going to be a JPEG image. Now, how do we get the JPEG function there? We have to use a place marker, which is going to be %s. That gives us a string, and then we can declare what that %s is in the next parameter as optional parameters. You could even do it again, %s, and then it'd take two more parameters at the end, which would define what that first %s is and what that second %s is. %s is only valid for strings, so if you want to put an integer there, it would be something else. Because it's a string, we'll go and use %s, and then we'll type the function, which is going to return the string, so date time dot get stamp, and that will put this, or what this function returns, into here. So it'll be datetime.getStamp.jpg, which will give us our JPEG image. Now, a common error with the camera is that datetime.getStamp returns the string, but it has colons in it. Colons are invalid. You can't actually store those onto an SD card per se. So you actually have to go through and you have to change those colons to we're going to use periods here. So we're going to create a temporary character pointer. That's kind of a complex aspect of C, but basically when I create a character pointer, I'm going to call it temp, and then I'm going to set it equal to file name. When I create that character pointer, it's basically referring to where this file name is. So I set this pointer equal to the file name. It's kind of a complex concept to wrap your head around, but bear with me here. So then we're gonna iterate through that temp pointer. So while *temp, and that will go through each. That will increment it. Well, that won't increment it in itself. You have to do ++ temp. But that while loop will increment each character through of file name. So then if we're going to do if the location of the character, so if the location of the very first character, it'll then go the second, then the third. So the location of the character we're on. So if *temp, that's the character we're on, and then equals colon. You do have to use a single quotes here. If you use double quotes, you're comparing it to kind of a string. Single quotes indicate in C an integer, so it actually turns that character right there into its corresponding ASCII integer. And then you're also going to do *temp. That's after the if statement. You don't need to put brackets there. Because there's only one line of code after it, and then equals dot. You also have to use single quotes here. So that just says if the current character we're on is a colon, then set the current character we're on to a period, and then move on to the next character. So that should change all of the colons to periods. And then after our while loop, we're going to go ahead and do camera dot get pics. That's the function which we'll use to get the picture. That actually returns a true or false, a boolean, which is the success. So if it successfully got the picture and stored it to the SD card, then it'll return true. So because our function here returns a boolean, we can just say return. So it'll also execute that. It'll execute that code, and then what it returns will return in our get picture function. So I'm just going to put in file name there. And to explain why it's not temp, it's because temp is this pointer. Temp refers to the location of each character in file name. It's not the actual name of the file. So that's that error there. And then I'll go ahead and build it, and it should compile successfully. And since the build is successful, we can go ahead and program our NSE board.
So now that we have the camera all set up and programmed, we can go ahead and plug it into a power source here, and ensure that our micro SD card and the camera is plugged in securely. As soon as we turn this on, you should see the green light on the back of the camera. And when you push the button, it should actually, the blue light should turn on, and you should actually see it take a picture. It will take a second, so just be patient. And you will see, now you can take multiple pictures, and we can take out the SD card and view them on a computer using a micro SD to SD card converter here. So we'll just go ahead and plug the SD card into the converter and go ahead and plug it into the computer, and you can view the images. So now if we go ahead and plug in our SD card and we navigate to the drive it's in, we can go ahead and click Open Folder to view files. You'll see that the two images we took are now saved onto that SD card. So if we open those up, you'll notice that the photo is there, it's upside down because we took the photo upside down and it's not focused very well. But if you take the time and you actually twist the lens on the camera, you can focus that so it actually works very well.